Yes, sir.
Bismillahirrahmanirrahim. So this is the question, and let us list up the given information first. We can see that a person of mass 70 kg, the mass is given m 70 kg, runs from the ground floor to the roof of a 10-story building, each floor being 3 meters high. So we are talking about a building. So this is a 10-story building, right? So he ran from the ground floor to the roof. That means he was here on the ground, and now he is on the roof. Okay, he is on the roof. So what is the height he has covered? We need to calculate this height, right? Now, if you notice, I have already mentioned that each of the floor is 3 meters high. That means this is 3 meters. This is again another 3 meters. So likewise, how many 3 meters has he covered when he went to the roof? 3 meters, 3
10.
meters, 3 meters. Total
10.
10.
10 into 3. Yeah. 30.
10 into 3, which is 30 meters. So his height from the ground will be 10 into 3 is equal to 30 meters. Okay. So 30 meters, yeah, and the time that he has taken for this is 30 seconds. T is equal to 30 seconds. Okay, now calculate the power of this man. So we have to calculate the power of this man. P is equal to what? Now we know power is equal to work divided by time. So what is the amount of work done? You have lifted a body to a certain height. So there has been some potential energy stored in it, right? That potential energy is equal to.
Yes.
So whenever you lift some body to a certain height, so what is the amount of work done? That is equal to the potential energy that is stored in the body. We have already discussed this, right? Whenever we do some work, we lose some energy, and that energy is stored in the body, either as potential energy or as kinetic energy, depending upon the situation of the body. If the body is moving, then we can say that the energy that has been stored is potential kinetic energy, and if the body is not moving, static, then we can say that it is potential energy.
Potential.
It has this potential energy. So how can we calculate potential energy? mgh. So mass is 70 kg, g is 9.8, and height it is 30, time is 30 seconds. So 30 30 cancel. Now kindly multiply this.
686.
686 watt. Either you can write watt or you can write joule per second. Okay.
Sir, I got 686 watt. But
Good.
then we have to find power, right?
This is what is power, right?
No, this uh, this is the answer, sir.
Yes, this is the
But
answer.
at last, I think I did something and I got the final answer wrong. But before, I got 686.
Now 686 তুমি পাইছো amount of work done.
Yeah.
তুমি ওখানে I guess 30 টা multiply করো নাই, তুমি 3 multiply করছো। আচ্ছা, anyway, so this is the
Yes.
solution, okay?
Yes,
Okay.
sir.
So sometimes they might ask you that calculate the power of this man in kilowatt. Now what is kilowatt? We already know that there is meter kilometer, gram, kilogram. So something like that, watt, kilowatt. So if I tell you to convert meter to kilometer, what you do?
By 1000.
Yeah, by 1.
You do?
Multiply by 1.
You divide by 1000, right? From meter to kilometer, if you want to convert, then you divide by 1000. So in the question, if they ask you to find the answer in kilowatt, but here you have got the answer in watt, then what you need to do? You have to divide it by 1000 to convert it to kilowatt. So 686 divided by 1000, then it will be in kilowatt. So it will be 0.686 kilowatt. Now there is another unit of power which is called horsepower. Okay, I will show you now. Horsepower. Horsepower, which is in short is written as HP. 1 horsepower. This is also unit of power. Now what is the amount of power? 1 horsepower is equal to 746 watt. Okay. So now let us say we had our answer 686 watt. But in the question, they have asked you that find or calculate the power in horsepower. Okay, many times you will see that in the question, the power is given as horsepower, or they might ask you to calculate the power in horsepower. So if you calculate the power in watt and do not convert it to horsepower, then what will happen? You might end up losing 1 or 2 marks, 1 mark mostly. So how to convert it from watt to horsepower? We will divide it by 746 watt. Sorry. When you divide it, it will become horsepower. So whatever value you get from here, that is the answer in horsepower. Okay. So now we know how to convert from watt to kilowatt and from watt to horsepower. Is it okay? Clear now?
Yes. Yes, sir.
Okay. Then we will move to our next topic. That is the last topic of this chapter, is efficiency. Okay, so let us discuss about efficiency. Before I start discussing about definition, let us try to understand it theoretically. Okay, now let us say we have a machine. To run the machine, I have to give it a certain amount of energy. Like whenever I want to run a machine, I have to give it some electrical connection by plugging it into some socket. Then what will happen? I'm providing it some energy, right? That is the input energy. I'm giving him some input. Now what the machine will do? It will use that energy and give me some energy back. So whatever the amount of energy he is giving me back is the output energy. Okay. So there is a ratio between this output energy and this input energy. That ratio is called efficiency. Now, if I explain it through a number, let us say I have a machine and to run the machine, I gave 100 joule of energy. But out of that 100 joule, now this is a fact that whenever you give a certain amount of energy to a machine, it will not give you back the full amount. Means if you give 100 joule, you will never get 100 joule back from it, because due to friction between the machine parts and some other reasons, what will happen? Some of the energy that you have provided will be lost. You will not get it back. So let us say out of 100 joule, you got back 70 joule. So what is the percentage of the energy that you got back? It is 70%. Out of 100, you got 70. So you can say that you have got 70% of the energy back from the machine, right? So the efficiency of the machine is 70%. So if I tell you that if the efficiency of the machine is 70%, then what can you say? You can say that, sir, if you give 100 joule energy input, you will get 70 joule. If you get 200 joule energy as input, you will get 70 into 2, 140 joule you will get as output. Understood?
Yes, sir.
এটা একটু এখানে লিখে বলে, যদি কেউ তোমাকে বলে দেয় যে efficiency of the machine is 70%, এখান থেকে তুমি বলে দিতে পারবা, if I give 100 joule, I will get 70 joule back. If I give 200 joule, see, it has been doubled. So definitely this will also be doubled, which is 140 joule. If you give 300 joule, okay, then you will get 70 into 3, that is 210 joule. Okay, in each case you will find the efficiency is 70%, because what is the equation of efficiency? For the first case, when you give 100 joule, got 70 joule back, that means output energy 70 joule divided by input energy into 100%. So 100 and 100 will get cancelled, 70 and percent. So it is 70%. Now let us check the second case. Eta is equal to you got 140 joule back divided by input energy is 200, so 100%. So 100 if calculated 2 have 2 দিয়ে 40 if calculated 70%. So if you continue like this, in each case you will get that the efficiency is 70%. So efficiency is the ratio of effective or output energy. This output energy is sometimes called as effective energy, because the energy টা তুমি back পাচ্ছ সেটাই effective, বাকি যেটা হারাই যাচ্ছে that is not effective. Okay, effective or output energy 2, the total given energy or input energy. যতটুকু এনার্জি তুমি একটা মেশিনকে দিবা ওটাকে ইনপুট এনার্জিও বলে অথবা টোটাল গিভেন এনার্জিও বলা হয়। তো এই দুইটার যে রেশিও সেটাকে বলা হয় এফিসিয়েন্সি। এখন স্টুডেন্টরা প্রায় একটা জায়গায় মিস্টেক করে, ইভেন আমি যখন স্টুডেন্ট ছিলাম তখন আমারও একটা জিনিস মনে থাকতো না, আউটপুট উপরে নাকি ইনপুট উপরে। তো আমি এটাকে মনে রাখি এইভাবে, ওই তার মানে ও আগে আই করে, ওই ও উপরে আই নিচে। তোমরা চাইলে এভাবে মনে রাখতে পারো, আর যাদের কাছে এটা লিঙ্ক লাগে তাদের তোমরা নিজে ডিফারেন্ট কোনো প্রসেস বের করতে পারো। ইটস আপ টু ইউ। সো এফিসিয়েন্সি একটা সিম্বল দিয়ে এক্সপ্রেস করা হয়, সেটাকে বলা হয় ইটা, আই টি এ, ইটা। এটা লিখে কিভাবে? অনেকটা দেখতে n এর মতো, কিন্তু তোমরা হয়তো অনেকে ভাবছো স্যার বোধহয় n একটু বেশি স্টাইল করে লিখতে গিয়ে পাটাকে একটু লম্বা করে দিছে। ঘটনাটা সেরকম নয়, এটা লেটারটাই এরকম যে n এর মতো লিখে পাটাকে একটু লম্বা করে দিতে হবে। বুঝতে পারছো? আমি এটা স্টাইল করে লিখিনি। এটা লেখার সময় n এতটুকু পর্যন্ত লিখে এটাকে একটু এইভাবে লম্বা করে দিতে হবে। ঠিক আছে? তাহলে এটা থিটা হয়ে যাবে। এখন ইউনিটটা আমি লিখি নাই, বিকজ ইউনিটটা আমি সবসময় তোমাদের থেকে জানতে চাই। এখান থেকে আমাকে দেখে বলো যে মানে এফিসিয়েন্সি এর ইউনিটটা কি? এফিসিয়েন্সি এর ইউনিটটা কেউ বলতে পারবা? এনিবডি?
No, sir.
Sir, no.
কেউ ট্রাইও করতে
Something,
সারপ্রাইজ।
no, something like that joule, then that by second.
জুল। তোমরা বলবা জুল
Yeah.
অথবা তোমরা
Then,
রং
sir,
আনসার।
joule.
আনসার তো
No.
তোমরা আসলে যে আনসারই দাও না কেন এটা রং হবে, বিকজ এফিসিয়েন্সির কোনো ইউনিট নাই। কেন ইউনিট নাই?
Unit নেই? কেন?
না, কিভাবে ইউনিটলেস হইতে পারে? কারণ এখানে একটা জিনিস দেখো, তুমি যখন উপরে আউটপুট এনার্জি নিচ্ছ, এনার্জির ইউনিট হচ্ছে জুল, আবার নিচে ইনপুট এনার্জি নিচ্ছ, এটার ইউনিট জুল। সো জুল আর জুল কাটাকাটি গিয়ে ইজ देयर এনিথিং লেফট?
No.
No.
তো এফিসিয়েন্সির জন্য যখন আসবে তখন আমরা যদি ইউনিট একটা পয়েন্ট লিখতেও চাও, যে তুমি লিখলা ইউনিট, তো তুমি লিখতে পারবা যে এফিসিয়েন্সি doesn't have a unit। ঠিক আছে, এখানে কোনো ইউনিট। ওকে, সো এখানে আরেকটা জিনিস তোমরা একটু খেয়াল করো, আমি এখানে আউটপুট এনার্জির পাশাপাশি অবলিক দিয়ে পাওয়ার লিখছি। তোমরা যদি চাও এটাকে লিখতে পারো আউটপুট এনার্জি ডিভাইডেড বাই ইনপুট এনার্জি, or sometimes in the numerical problem you will see that they have written output power divided by input power. That is also called efficiency. No problem, it will give you the same answer. So either you will write output energy by input energy, or you will write output power divided by input power, depending on the given information in the question. Is it clear?
Yes, sir.
Okay, so I'm going to send you a picture of a mathematical problem. Kindly solve it and send whenever you can. Okay, I want to see who is the top 3 who can send me the solution of this problem. Okay, that will be related to efficiency, and you make mistake, no problem. I just want to see who responded first. Okay, acha. So today we will end our class here. With this topic we have come to the end of this chapter. Only the mathematical problem that is related to efficiency is left, which I will be sending you through a picture. You will solve it and send me, and inshallah in the next class I will say that who got the correct answer, or in the group itself I can say that who are the top 3 who sent the correct answer. Okay, so after that we will solve 1 or 2 creative, and then inshallah we will go to the next chapter. Okay,
Sir, shall we send that one by today?
huh?
That mathematical problem we have to send by today?
It's up to you. It's I will not give you any deadline. I just want to see who are the first 3 who sends me.
Okay, sir.
Whenever you send it.
Okay, sir.
Okay, thank you very much for joining. Assalamu alaikum warahmatullahi wabarakatuh.